Yes, in this video, we will discuss iteration with the selection. Yes, in the iteration, we need to select a decision making. So I am Dr. P.V. Sena from CBIT. So the basic symbols used in this video are including this input, output, and processing symbol. Then we are using a loop. In this loop, we are using these selection statements. In order to make decisions, we are using a selection statement in the loop. So the loop is contains initialization. This condition in this, if the condition is false, then we go for the selection statements. If the condition is false, the loop goes to execute. In that, I am writing a selection statement. After that one, this incrementing the I value. So the example is find the factors for the given number. Yes. So you know this mathematics is the backbone for computer science. Suppose my n value is 6. Simply we know the factors for 6 is 1, 2, 3, 6. So we need to do this for this a simple flowchart. We are developing a flowchart for it. So for that purpose, I am reading my n value. N value here I am passing 6. So initially I is a variable which is initialized to 1, then the loop goes to execute. So the loop is begin here. So 1 is greater than 6. This condition is false. Then I am selecting whether this 1 is a factor for 6 or not. N modulo by I. This modulo division checks for the remainder. So 6 modulo by I. This condition is true. Then I am displaying. So 1 is factor for 6. Then I am incrementing this I value. Again, this loop goes to executed until this condition becomes true. Once the condition is true, then it will come out of this one. So 1 is factor for 6, 2 is factor for 6. Similarly, 3 is factors for 6. 4 is not a factor. In this, 4 is not a factor for 6. 5 is not a factor for 6. 6 is the factor for 6. So I am displaying the factors for the given number in this program. So once you find the factors for the given number, then you check whether the given number is perfect number or not. So the simple perfect number is a number, sum of factors is a double equal to double of the given number. Yes. So sum of factors 1 plus 2 plus 3 plus 6. So this is 12. This 12 is nothing but 12 is equal to double of the given number. 6 to the 12. So then we can say that 6 is the perfect number. So this is my flowchart. Initially, I am taking the variable n value I am taking it is 6. Then I am taking the sum value is 0. So I is 1 initialization. Then I am checking this condition. If the condition is false, then n modulo by I. So I am checking this factor. Yes, at the same time, I am printing this factor. Then I am incrementing the sum value. Sum is equal to sum plus I. So I am adding this I value to this variable sum, which is initially sum is 0. Then I am incrementing I value. I is equal to I plus 1. At the end of this loop, I am checking whether the sum is equal to the given number double of the given number. If this condition is true, then I am telling the given number is perfect number. Remaining case, it is not the perfect number. Yes. So now the 6 number of factors is 1, 2, 3, 6. Once I am adding this number of factors, the results will be 12. 12 is equal to double of the given number. So then 6 is the perfect number. Here this is in this example I explored it. So next check whether the given number is prime number or not. So this prime number, it is a very simple logic, a number which is divisible by 1 and itself. So else we can check the number of factors is 2. The number of factors is 2. So the factors including 1 and itself. So I am taking my n value is 7. So in this case, what we need to do, we are counting the number of factors. Initially count is a variable which is initialized to 0. I am reading the number n. So I is a variable which is initialized to 1. So if this condition is false, then I am checking whether it is a factor for the given number or not. So 1 is factor for 7. So next, except 7, there is no other number is factor for 7. So for 1 and 7, I am incrementing the count. So for 1, the count becomes to 0 plus 1. Again at the 7, count becomes to 1 plus 1, 2. At the end of this one, I am checking the number of factors is 2. So count value is 2, then I am telling n is the prime number. So remaining cases, n is not a prime number. So this is my output. 1 is factor for 7, 7 is factor for 7. In these two cases, number of factors is 2, my count value becomes to 2. Then we can say that the given number n is the prime number. So if possible, you can try to optimize it. If possible, you try to reduce the number of symbols evaluated in this one. So you make the simple hint is any number is divisible by 1 and itself. In that case, you can start with 2 to n minus 1. You need to start with the 2. This I value starts with a 2. So you need to check to n minus 1. The number of factors count you need to check for 0. So in this way, you try to optimize it. So next is check whether the given number is palindrome or not. So number palindrome. So what is number palindrome? If you are reverse the given number, then you are getting the same number. Then we can say that the given number is palindrome number. So what is the logic? Reverse the given number. If given number after reversing reverse number and the given numbers are equal, then we can say that it is the number palindrome. So in our logic, what we are doing here, dear children, I am reading my number n value I am reading. So this n value I am assigning to some temporary variable m. Y means there is a change in n values. The n value is changing. So I am taking some more variable reverse. So which is instance to 0. Then I am using my loop. I am checking this condition n is less than or equal to 0. So I am taking the n values 1, 2, 3, 2, 1. So it is less than or equal to 0. This condition is false. Then I am checking the remainder. So remainder is equal to n modulo by 10. I am using this floor function. Floor function means it will adjust to lowest integer value. After that one, I am making the reverse. Reverse is equal to reverse into 10 plus remainder. So what I am doing here logic is reverse is equal to reverse into 10 plus remainder. So in the case of 1, 2, 3, T1, 2, 1, the remainder is 1. So initially reverse is 0, 0 into 10, 0 plus 1. So the reverse number becomes to 1 here. Next, n is equal to n divided by 10. Here again, I am using this floor function to adjust lowest integer value. Again, this loop will be executed until this condition becomes to true. If the condition is true, then it will comes out of this for loop, this loop, right? In programming language, it is reverse. If the condition is true only, the loop goes to execute. In Raptor, if the condition is false only, the loop goes to execute. So after that one, I am checking m. What is this m? The given number n is stored in this temporary variable m. Y means n is changing. So m is equal to the reversed number. If this condition is true, yes, I am telling the given number is the palindrome. In other cases, it is not the palindrome. So m value is 1, 2, 3, 1. Reverse number is also 1, 2, 3, 2, 1. These two are equal. Then I'm getting yes, 1, 2, 3, 2, 1 is the palindrome. If possible, you need to try to optimize it. How can you optimize means? So you need to check 1th location, this 0th location with last but 1 location, second location with last but 2 locations, right? If you are trying this, then the number of symbols evaluated will be reduced. That is the optimized logic. In this way, you can try the other problem, sum of all prime numbers below 2 millions. So in optimized way, for your reference, this link, yes, this reference link, you need to follow this reference link. If you need some optimized logic, we have developed nearly 7 to 8 logic, you need to find which one is the best. So next is given number is angstrom number or not. So how can you check the number is angstrom number or not? Means suppose if you take the number 153, 1 cube plus 5 cube plus 3 cube is equal to 153. 1 cube plus 5 cube plus 3 cube, right? So then it is equal to the given number 153. Then we can say that the given number is angstrom number. So in next videos, we will look into this next loops.